Hello everyone, welcome to Arun's Tech Force. I am Arun Barua and today I am starting my LangChain Python tutorial series. In today's demo, I will explain how to design an AI assistant for enterprise customers. So let us begin. Let me explain the architecture of this project. Okay guys, this is an AI Research Copilot that I have designed. So I will start with explaining the backend architecture of this project. Before I go through the architecture, let us see the project once, how it looks like. This is the project. It is having backend as well as frontend. Okay. Now let me run the backend. Okay. So let me just clear it up once. Yeah, backend is now running. Let me also clear the cache for the frontend. I want to show it from the scratch. So this project is running. Let me open a browser, Google Chrome. There it is localhost port 5000. The UI looks very simple. This is a AI Research Copilot. Okay. So basically, people can use this AI Research Copilot to do research. For example, let me just type this one. I want to know latest trends in AI agent and LLM reasoning, and I have given search parameter of 5 because I am using search API internally. Okay, and let it be one iteration. Click on generate report. Then we have to wait for say 1 or 2 minutes. Anyway, I will fast forward it. We got the report. Okay, these are the findings for the topic, and these are the references, and these are the sources. Now if we click on this, it will go to this particular source. Okay, so this is a conference paper writing. It has search. You can get it from this place. Okay guys, now how this project works, that is what I want to show you. How do we design for enterprise grade system? Okay, so let us just go back to the design architecture document. Here I want to explain now. Introduction. Okay, this is a AI Research Copilot, and it is a web-based application designed to automate research tasks by generating a report based on user-defined queries. So the backend is built with Python and FastAPI, orchestrated a pipeline of planning, researching, gathering, persisting, writing, and refining content using AI services. We use LangChain, OpenAI, scalable, and Chroma DB. Okay, now this document details the backend architectural design, focusing on the design patterns employed, their rationale, and their features, ensuring a robust, extensible, and maintainable system for local testing and say potential production deployment. Okay, I design in such a way that it can be we can make a SaaS application also. Now let us see the high level architecture, how it looks like. Okay, so here is the architecture in top down approach. Okay, let me just maximize a little. Okay, I think I have to minimize a little. Okay, anyway, you please see here. This is the front end Flask application. Okay, it has a post request that is used to provide the request, and after that the request is passed to the backend and backend process it and the response is given back. No big deal. It's a very simple design. Okay. Simply I have written HTML and JavaScript and nothing more. The main thing comes here in our backend. So I have designed using a layered architecture. This is the top layer. We have main, then models, and here I use dependency injection pattern. Next is our orchestration layer. It has the base orchestrator, that is abstract, default orchestrator, that will be the sequential execution, and async orchestrator that I have written for parallel execution. Okay, and this design pattern is template method. Okay, so this is our research pipeline flow. When you enter something, a request, these are the steps the agent go through it. We have the planner, researcher, caller, Next is the persistence. Then we have write, redefine, and finally output. Next is our service layer. We have the LLM service, embedding service, agent strategy. Here we have implemented the strategy and design pattern I followed. Here is the strategy pattern. Next is our repository layer. It consists abstract interfaces. They are the vector source repository and vector repository. Source repository, where source repository uses the SERP API, source API.io actually for integration. Next, vector repository, Chroma DB to persist the data, and this is actually a repository pattern where data abstraction layers, swappable data sources, fallout tolerance, all those things are taken care of. Okay, guys. Next is our utility layer. So few utilities I have created, that is to fetch the URL content, convert it to markdown. And this is where I use the circuit breaker pattern. And these are the external services I have just shown. OpenAI we are using, GPT-4o mini for search, that is the searchapi.io. For vector store, I am using Chroma DB. For the framework, I am using LangChain, and these are the configuration settings in .environment. And this is basically the legend that shows these are the components. This block is just for explanation which design pattern I use, and this is our external service. Okay, guys, let's come to the backend architecture. Here I will discuss in detail what exactly is done. This backend layer is organized into a layered architecture promoting separations of concerns and modularity. The structure is located in our backend code. Let us see the code. Let me go to the code, and you see this is our backend, right? Here we have app. Inside app we have the repositories, we have services, we have the utility classes. And in this area we have our main.py file, then this is the models.py, this is the config.py. What this main.py do? It handles the request input validations, and it also take care of the cross-origin resource sharing problem. Main has few endpoints that I will show you. Where is the main? So this is our main class. We have, included the services, the repositories, orchestrators above. Then we have set our middleware here. These are few get methods which we'll be internally using. Get LLM, get embedding service, get vector repo, get search repo, okay, get the research strategy, get the orchestrator. Then these are our endpoints. /health is just for a health checkup. This is for vector info, and this is the run agent. Okay, you have seen the demo, right? We are basically calling this run agent. Okay, then let us talk about the orchestration. Okay, models.py. Actually, this is a Pydantic model. Where is models.py? Import Pydantic. Okay, from Pydantic we import the base model. Then from typing we import the list, option, dictionary, any. So we created a class agent request from the base model. Task is str, that is string. Max search result optional we have given, and also assign default value of option is 5, and refine iterations option in here default value I have given 1. Next is class response, agent response. Okay, inheriting from the base model. Their ID is str, report is again str, and source is a list. Inside that list we keep a dictionary. Okay, and the key is again string, and value would be any. So what is the purpose of this orchestration layer? Let us now discuss. Okay, I will be discussing now orchestration layer. This is the orchestration layer. Here we are using from ABC. We are also creating some abstract class. Okay, then using LangChain schema and LangChain text splitter, using the recursive character splitter, from LangChain document store importing the documents, and these are taken from import from our app.models. Okay, and these are from app.services and utils. This is the base class I have created, base orchestrator. Okay, and we'll have this constructor function taking the parameters self, LLM service, and vector repo, passing the Chroma repository. Okay, then there is one execute method, and it is taking request, agent request. This is the arrow function we are using, and this is the rest of the code. Okay, then here are the template steps. I call, right? I told you that we are using planner method. This is plan. Okay, then search result gathered, report.md. All of these things are taken care of it. Then important thing is this is using underscore plan as our abstract method. Okay, and we are passing, so that these are actually these will be used actually in from the from the class that inherits, that in those part this method will be implemented. Okay, so just passing from here. This is the gathered text method. Okay, basically it from the search result it gathered those particular things. This is the abstract write method. This is the refine method, and this is the default orchestrator. Okay, this default orchestrator, we have two orchestrator. One is the default orchestrator that will be using for synchronous operation, and in case we deploy it in AWS, say make it as a large SaaS application, at that time we can use the asynchronous orchestrator for the parallel execution. That is also defined. Okay, so this will be the base orchestrator. It has this underscore plan. Here we are now defining it. This is the research. Okay, then then this is our async orchestrator class for the parallel execution, as I said. Okay, all of these things are written over here. Next we discuss about the services layer. So the purpose of the services layer is to encapsulate the business logics for the AI interactions and agent. There I have written the LLM service, the embedding service, the agent strategies. Let me show you that services, right? Okay, this is the LLM services. There we are using from the LangChain chat OpenAI, and this is the LLM service. Okay, and this is just the invoke method. And this is a note for me for production if I need to consider what I need to do. It's just a note for me. Next is our embedding service, where I use the LangChain OpenAI embedding. Okay, so here I am passing the OpenAI key. No big deal, right? Next is agent strategies that define strategies for planning, researching, writing, and reviewing. This guy. This is the planner strategies. Again, this is taking the abstract base class from the ABC, and this is the plan, we are passing it, and this is a class that is actually default planner strategy is inheriting this planner strategy, and here we have defined the planner. This is the system prompt. You are the planner agent. Okay, given the user's high level research task, produce a short numbered plan with 3 to 6 steps, and also telling that return as a JSON array of strings. Okay. Next is a research strategy. This is also created as an abstract base class. Similarly, write strategy. Okay. Then we create the default writer strategy. So this will be responsible for writing. Okay. Then here this is the system prompt. You are a writer agent. Compose a concise, factual, markdown report. So include TLDR summary, key finding, analysis, implementation, references, all of those things. That's why you have seen this report. Okay, this method was responsible for writing this. So you are getting TLDR, key findings, analysis, implication, and references, whatever things we defined here. So this function has taken care of it, and we are getting the result. Okay. Next is a reviewer strategy. Okay, this is again from the abstract base class we created, and default reviewer strategy is actually implementing it. This is where it is reviewing. Okay, so this is the system prompt for reviewer agent. So you are a reviewer agent. Okay, critique markdown reports for factual accuracy, clarity, citation, and return JSON score 0 to 100. Issues listed and improvement that is string. Okay, like that. So I have given the system prompt for that, and this class is for our SERP strategy. We are using this for searching. Okay, so I told you about the service layer, right? Now let us talk about the repository layer. The purpose is to create abstract data access for search and vector stories. There we have the base.py, that is abstract interfaces for the search repository and vector repository. We have then search repository that integrates search API, and vector repository that manages Chroma store for RAG persistent layer. Okay, let us see those also. Where is that guy? This is the base. It is just an abstract class, right? Search repository abstract, and vector repository, this is also abstract. And here search will implement it. Okay, search will implement it, and it goes to the search particular endpoint where search will be done. Okay, and this is the vector repository that implements the class Chroma vector repository. Okay, it will inherit from this vector repository, and it takes care of persisting the data in our vector DB, and it has the add document. It is having the similarity search where I have mentioned top k is equal to 4. Okay, so okay, this is it for that, and this is just an utility layer for fetching and formatting. Fetcher for fetches articles with the circuit breaker, and markdown converter will convert markdown to HTML. Okay, now let us now, okay, that code also let me just show you quickly. Utilities fetcher, okay, we are using the circuit breaker @breaker, and this is the method I have written. Fetch article text from the URL with circuit breaker for fault tolerance, return empty string on failure. Okay guys, and this is the markdown converter. This will convert the markdown to HTML. Okay, now let me just discuss about the design patterns, why I use these design patterns. Okay, the backend leverages several design patterns to achieve robustness, extensibility, and maintainability. So below we will discuss this, why I use it and what is the rationale and features. First of all, I use dependency injection in the main.py. Okay, so FastAPI depends on mechanism that injects dependencies into the endpoint. So factory functions where I used get LLM, get embedding service, get vector repositories. Okay, get search repo, get search strategy, get orchestrator creates instances of the LLM service, embedding service, Chroma vector repository, search API repository, research strategy, default orchestrator, async orchestrator. Okay, so why I have chosen it? This enables loose coupling between components. Okay, LLM service can be swiped with different provider. For example, we can use Anthropic, Claude, or we can use Mistral or Google Gemini, anything. That is why it is designed in such a way that we can change it, right? It's loosely coupled. Okay. Then it simplifies the unit testing by allowing dependency mocking, mock the LLM service in test. Next is it supports runtime configuration, switch between the default orchestrator and the async orchestrator. Okay, that is why I created. So the program that I have shown you, it uses the default orchestrator because I myself is using right in this particular laptop. But when I deploy it, say creating it as a SaaS application, at that time this async orchestrator, it will be very much beneficial. Okay, because we need to do parallel execution. Next is the features extendability, add new services, repos by updating the factory functions. For example, get LLM for Olama or Llama or Mistral. Okay, testability, already told it right. We can mock dependencies in the test, unit test.mock. Then configurability, and we used to configure using the environment control behavior. Say search strategy equal to SERP API. If it is Google API, then we can use Google Search API, or if it is a DuckDuckGo, we can use that also. Okay. So robustness validates dependencies at the startup. We are logging errors, okay, for the invalid key and all, so that our program become robust. Next pattern we use is repository pattern. Okay. So in the file repositories base.py file, search repository.py and vector repository.py. So there I have used the repository pattern. Okay. So base class define an abstract interface with a method like search and add document. Okay, concrete implementations are done in search repository that uses the search API, search.api.io, and in vector repository.py. We are using Chroma vector repositories, right, for managing vector stores for document persistence and also the similarity searches. Why we have chosen that? Abstract data access that allows seamless swapping of data sources. We can swap from, say, search API to, say, Taveli, or say from Chroma to Pinecone or Quadrant, Webit, like that. Okay, isolates the data logic from business logic, improving maintainability and enables fallback. Okay, next is, okay, that I have already discussed, right? Next is the strategy pattern. So this strategy pattern is used in service layer agent strategies. So there defines abstract research strategy, planner strategy, writer strategy, and reviewer strategy with concrete implementation by these SERP API strategy, default planner strategy, default writer strategy, and default reviewer strategy. Okay, why I have chosen this one? This allows pluggable agent behavior. Switch SERP API strategy to, say, perplexity strategy. We can do that. Supports experimentation, A/B testing strategies. Okay, for example, encapsulates the agent logic, keeping orchestrator.py clean. Features: it is flexible, we can reuse, and it can be configured as we are using, the environment driven strategy, and it is easily maintainable. Okay. Next, we use circuit breaker pattern in utilities fetcher.py. So pybreaker.circuitBreaker to handle the URL fetching failures. That is why we use this one. Okay. So it prevents cascading failure from unreliable URLs or APIs. Provide graceful degradation, means it will return empty string on failure. Next, simplifies retry logic for external HTTP request. Again, the features are fault tolerance, okay, resilience, simplicity, extendability. So we can use Redis state storage for distributed system, for example, if we wish. Okay, it can be done. Next is template method pattern. So this template pattern is used in the orchestrator.py. Okay. So base orchestrator defines a template method execute with abstract methods, that is underscore plan, underscore research, underscore write, and concrete methods, that is underscore gather underscore test, underscore persistent underscore doc, and underscore refine. Okay guys, so this is it. This is how I define it, and I will be uploading the code for you guys, so you can download it and see. I will upload it in my GitHub. Okay, so why this particular a template method is chosen? Ensures consistent workflow across the orchestrator, if whether it is sequential or async. Okay, allows customization via subclassing. Say example, async orchestrator for the parallel search. Simplifies pipeline maintenance by centralizing code logic. Okay, features: it enforces plan, research, gather, persist, write, and refine pipelines. Extendability: subclasses can override specific steps. Okay. Robustness: again, a fallback default plan I think I have implemented. to ensure the pipeline completion, performance. Async orchestrator uses async io.gather for parallel searches that reduces latency. So this is the architecture, overall architecture of the backend system. Front end is very much simple. I use simply index.html in the template and app.py. It's nothing. It's very simple. Okay. So in conclusion, the AI Research Assistant Copilot is designed for robustness, extensibility, maintainability, leveraging the layered architecture, and 5 key design patterns I implemented: dependency injection, repository, strategy, circuit breaker, and template method. These patterns enable loose coupling, fault tolerant, pluggable behavior, and consistent workflows, making the system suitable for local testing and future upscaling. Okay. So the front end complements the back end with a simple user interface. I have also implemented the logging. Okay. So this is an overview of AI Research Copilot that I have designed and developed using Python, FastAPI, LangChain, OpenAI, Search API, and along with Chroma DB. Okay, thank you so much, guys. Thank you and have a nice day.